Hello everyone, welcome to today's webinar. Today we will go over the last section in Unit 3, Graphing, and that's the part 2 of the unit. If you would like to study for the whole unit, you need to go back for as well webinar number 1, part 1 of this unit. Today we will go over linear equations. We will learn how to graph linear equations. In the past webinar, we have learned how to graph just random form of equations for straight lines. Today we will study specific forms for linear equations and how to extract the information from those equations and graph the lines, knowing the equations of those lines. Also, we will learn how to graph and find the solution of system of equations without actually algebraically solve the system. My name is Mariam. I'm your math instructor here at Penn Foster. I'm certified to teach high school math in the state of Pennsylvania and also have a master's degree in education. Today in this webinar, we will go over the most challenging topics and kind of questions in the second section of Unit 3. There is a couple of self-check questions during our webinar today, and those self-questions are not graded. Those questions are just given for you as an opportunity to self-assess yourself and see if you are okay with the topics that we have discussed so far in the webinar, or maybe you need to seek some help on those topics. Your questions are welcome, of course, and the raise your hand feature does not work in our webinars. The only way that you are able to ask questions is to type in your questions in the questions box. All registrants for this webinar, including the attendees, will receive a recording for the webinar. Today, specifically, we'll go over the general form, the point-slope form, and the point-intercept forms of the linear equations. And linear equation is just a fancy name of saying an equation for a straight line. And that's why we call it linear, like a line, just one or two, three variables, and those variables has an exponent of 1. So it's linear equations. And also, we will go over graphing system of equations. So let's start with the general form of an equation for a straight line. Now, we're not going to invent anything. Everything is given to us. The only thing that we need to know is to identify which form that we will be working on in each question, and also how to answer that question using the correct method and correct way of doing things. So the general form is given to you as a times x plus b times y plus c equals to 0. What does that mean? It means that you are able to write the equation of a straight line using the general form. The general form says that the equation should have an x. This is a variable, just x, and that x has a coefficient, and which is a number that is appearing in front of that variable. It's a. So a is not a variable. A is actually will be an actual value, 5, 6, -1, -2, 10, and so on. And also it has to have a plus or a minus, and then b times y. Y here again is a variable. Y will stay a y in the actual equation, and b is a coefficient for the y, any number, and then plus another number, just a number with no variables here, and everything here has to equals to 0. If you're able to put the equation of this line in this form, then the form that you arrived at is a general form of the equation. What would be some questions asked about that? How would you be able to practice that concept? Well, you may be given an equation like that, graph, and then you have a long equation. You can put that equation, it's a long equation, and obviously it's not in general form. You can transfer or transform that equation. You can rewrite the equation in general form. And from there, we're able to use the double intercept method that we have spoken about on webinar 1 to decide on 2 points that lie on this line and plot them on the coordinate plane that you have here on the screen, and connect the points and Here you go. That would be the graph of the line. Let's do that together then. So you have a long equation, 5x minus 2y minus 5 plus x equals to y plus 13. And you're just asked to graph the equation. The first thing I'm going to do is reduce the equation. I see like terms. I see a 5x and I see an x. And we know from unit 1 that 5x and x are like monomials. We are able to combine them. And I'm going to combine them by adding 5 and 1. Remember, 1 is there. So 5 and 1 is 6x. And then minus 2y minus 5 equals to y plus 13. Now I need to bring everything over to this side to put it in general form. See, everything on one side and then a 0 on the other side. I'm going to do that by subtracting y and subtracting 13. I'm going to do that on the right-hand side and the left-hand side to keep the equation balanced. Remember? Minus 13, and then rewrite the equation. All I'm doing is putting everything on the left-hand side. 6x will just remain as is, minus 2y minus y. That will give you minus 3y. Minus 5 minus 13, it's minus 18, and these will just cancel out, equals to 0. Now the equation in general form, see, 6, which corresponds to the a, and then x minus 3, which corresponds to the b. So b actually here is a negative 3, and then we have a y, and then minus 18. So c here corresponds to negative 18. So this equation in general form already. Now we are asked to find the graph or graph the line. So this is not the answer. We need to use the general form to graph the line. So if you remember from webinar part 1 for this unit, we said the easiest method to graph a line is the double intercept method, which is actually setting the x equals to 1 and figure out the y value. And then the other time, you're going to set the y equals to 0 and then figure out the x. So once x equals to 0, you figure out the y, and then once again you're gonna set the y equals to 0 and find the x. And this method, the double intercept method, you're actually finding the y intercept and the x intercept, the points that the line intersects with the y axis and the x axis. So to graph the line, as you remember, we need at least 2 points. So my method is to say, well, if x equals to 0, what would be the y? And once again, if y equals to 0, what would be the x? Well, I have the definition of my line. I can just plug in 0 in place of x here and solve for y, and that would be the value of y. Let's do that together. So 6 times 0, because x is 0, minus 3y minus 18 should give us a 0. Now that's gone. Minus or negative 3y minus 18 equals to 0. I need to bring everything on the other side of the equation, then add 18 and add 18. So you have negative 3y equals to 18. Divide over negative 3 and divide over negative 3. Then y equals to negative 6. Your first point is 0 because x was 0 and the y is negative 6, then it's negative 6. The first point on that line is 0 and negative 6. So let's plot that on the graph, on the coordinate plane. 0 and then go down 6 units. 1, 2, 3, 4, 5, 6. So that's the first point here. 1 point is not enough. We need another point. So let's set y equals to 0 and solve for x. So we're going to have 6x minus 3 times 0 minus 18 equals to 0. Now we're going to have 6x that's gone minus 18 equals to 0. Add 18 to both sides. So you have 6x equals to 18, divide over 6 and divide over 6, x equals to 3. So your point is 3 and 0, because y is 0, and that's why we have the 0 here. So the second point on that line is 3 and 0. So that is the y-intercept, and this is the x-intercept. And then connect the points. So that would be the graph of the line. So I'm going to show you the graph right now. Here's the points, and here is the line. So we were able to use the given equation, change it to the general form, use the double intercept method, and plot 2 points and connect, and that would be the line. Any questions? Anything that didn't make sense or was not clear? You can type in your questions in the questions box. If you didn't join the introduction of the webinar, you're able to ask your questions by typing your questions. I'll be able to see your question and the person who asked the question as well. So this is how we use the general form. It's pretty easy, given that we have covered lots of the way that we solve equations, how to graph a line and everything like that on the previous webinars. So the only thing that is new to us is the form itself. That's it. Let's go with a self-check question. The general form of the linear equation 2y minus 2x plus 3y equals 20 plus 2x is. So obviously this equation is not in general form. What would be the general form of this equation? So your job is to simplify this equation and put it in the general form. So I'm going to leave that question for about 30 seconds and then change my screen to the same question, but that time you'll be able to actually input your answers and be able to see how many % of you got it correctly and not correctly, and it's not for grading or anything, just to see if that topic is one of the topics that I need to maybe put more examples in future webinars, or maybe I have to go over it again. So you can work on the question, and I'll change the screen in a few seconds. Okay, I'm going to change the screen now to the same question, but I will give you the option to actually select the answer. For those questions, I will share my final answer. If you need me to go over one of those questions, I'll go over that quickly. So the final answer, the right answer for that is choice B. B is the general form, the correct general form for this equation. Okay, let's move on to a different form. So this form it's an equation for a line. It's nothing different, but the way you set up the equation is different. So the point slope form uses one point that the line goes through it, and also the slope of the line to come up with the equation of the line. In this form, y is just a variable. It will stay as y. Y1 is the coordinate of that point, the y coordinate of that point that the line go through. M, as you know, M is the slope, how steep or how this steep the line is, and whether it is inclining or declining. That would be the slope. X would be a variable, just X, it will have to stay as X, and then minus, and then X1 would be the X coordinate of that point, the same point that the line goes through. If we have a point known that the line goes through, and we know the slope of the line, so we can easily set up the equation and just write it down in the point slope form. Now, how would we graph? If we are able to look at the point slope form of a line, how would we use this form to graph the line? Now, what I understand from this equation, if I compare this equation to the general form, the standard form, the template of the point slope form, I realize that I am given a point where the line is passing. So this point is the x-axis here, since that's the x1, and this is the y1. So the point would be 5 and 3. Remember that the point is not -5 and -3, because the formula has a minus, and this is a minus. So that's why our point is 5 and 3, not -5 and -3. This is one of the common mistakes that students would do with this kind of formula. So the point that we know that this line passes through is 5 and 3. Let's plot 5 and 3. We're trying to graph the line, so we need 2 points. We know 1 so far. So 5 and 3, 1, 2, 3. So that would be 1 point that the line passes through. We need another point. Now, with the form that we have, the point slope form, we do not have another point. I mean, we can use any value of y, any random value of y, and solve for x, and that would be another point that you can use to graph the line. But also another way that is given to us in the study unit is to use the slope. To use the slope to find out the second point. And the way we're going to use the slope is to look at the slope as a fraction. M, which is the slope, equals to -2, and actually we can say it's a -2 over 1, because -2 over 1 is the same as -2. But we chose to write it as a form of fraction because remember the formula for the slope from webinar part 1, m equals to the rise over the run. So having to write this in fraction form, we can say that, well, -2 is the rise and 1 is the run. How can I use it, though, to find the second point? Well, I can go from the point I have on the coordinate plane already, which is 5 and 3, rise, so go vertically up or down 2 units. But since we have a -2, I have to go down 2 points, 2 units, 1, 2. But also I have a run of 1, +1. So the run gives us how many units we go left or right, but we have a +1, so we go to the right 1 unit. So this is the second point where the line passes through. So now we have 2 points. We have 5 and 3, that was from the equation, and from using the slope we were able to locate the second point, which in this case 6 and 1. So 6 and 1 is the second point. So connect the points and you will have the straight line graphed on your coordinates. So here is the line. And if you remember from webinar part 1, we said that any line that has a negative slope is a declining line, meaning that if we go from left to right, that line decreases, that line declines. So without even graphing, without just looking at the graph, I can decide that this line declines by looking at only the slope. It's a negative slope. Any questions? Okay, let's go to the second equation. It's a different line with a different equation. This equation, if you compare this with the point slope form, it is the point slope form for this line. So in that form, we are given 1 point. So the point is 1, and -4. And why did I say 1 and -4, not 1 and 4? Because the formula has a minus sign, so this has to be of the positive. This is the x coordinate. Now the y coordinate, the formula has a negative or a minus, but it has a positive in the actual equation. So this must have been y minus -4, and that's why it was written as a plus, because negative times a negative is a positive or a plus. And that's why we say that the y coordinate of that point where the line passes through is a -4. So let's plot the point 1 and -4 on the coordinate plane. So 1 and then go down 4. So that would be the first point. Of course, we need a second point, and we have given a slope, and that slope is actually 6/1. This is the rise, and this is the run. Now 6, we're going to start from this point, and it's a positive 6, so we're going to go vertically, but it's a positive, then go up 6 units, 1, 2, 3, 4, 5, 6. And then it's the run is 1, positive 1, then go to the right once. So this is the second point where the line passes through. So far, this point is 1 and -4. That's from the equation. From using the slope, this point is 2 and 2. All you have to do, which is the last step that you need to do, is to connect the points, and you will have the graph of the second line. And here you go. Now this line in orange is inclining because the slope is positive, and even from the graph, from going from left to right, this line goes up. So this line inclines. That's it. Any question? Anything that was not clear? Okay, let's look at another example. Another example with the point-slope form. Find the equation of the line that passes through the point -4 and 6 and has a slope of -3. Now, the question did not specify to put the equation of the line in the point-slope form, but what's given in the question makes me use the point-slope form, but because what is given is a point and a slope. So the easiest way to go about that is just to use the point-slope form. So by looking at the form itself, it says I have to have a y and then a minus. The y coordinate of the point is 6. It's not -4. Well, y1 appears first in the equation, but we need to make sure we pick the right coordinate. It's 6. So -6 equals to m, which is the slope, -3 times x is a variable, and then minus x1. Well, x1 itself is a -4, but we have a minus here. That makes me write it as +4. That's it. And this line without graphing is a declining line because it has a negative slope. That's it. So in this way, I just use a point and a slope, and I came up with the equation. Let's look at another question. Write the equation of the line that passes through -9 and 8 and another point, 0, 1, 5 in point slope form. This time the question specified which form they want you to write the linear equation for that line in. Now, we know that the point slope form uses a slope and a point, but in the question I have 2 points and no slope. How can I use the givens to write my equation in point slope form? Remember from webinar part 1, we know that the slope equals to y2 minus y1 over x2 minus x1. The y2 and the x2 comes from one point that the line goes through, and y1 and x2 comes from another point that the line goes through. Well, I have 2 points, so let's use them. And the way that I like to do that is to label my coordinates first before I use my formula so I don't mix up. So let's call this y, or x, I'm sorry, x1 and y1, and this is x2 and y2. And this way I just have to plug in the right values in place of each of the variables. Y2 is 5, so 5 minus y1 is 8 over x2 comes, it's a 0, and then minus, I have negative 9 for x1, so that makes me write it as plus 9. Equals to, do the math, 5 minus 8 will give you negative 3 on the top, and 0 plus 9 itself, 9. And then reduce the fraction, divide over 3, and divide over 3. So this fraction actually is a negative 1 over 3. That is your m, your slope, negative third. So I have a slope and I have 2 points. I can choose whatever point I would go for. I would go for the one that does not have a 0 in the x or the y. So that way I'm able to use an actual value and I'm not going to be eliminating any of the variables there, x or y. So I'm going to use negative 9 and 8. So the equation would be y minus y1 would be the 8 equals to m negative 1 over 3 times x minus, and then plus, because it's a negative 9, 9. And that would be the equation. If you're curious and want to know how would the equation look like if you choose the second point over the first point, I mean, you can. Let's do it together just to, you know, show you different ways of writing the equation. So I'm going to use the point slope form. So y minus, the y here in this case is a 5, equals, the slope is the same, 1 over 3 times x, and then minus a 0. I can simplify that saying it's y minus 5 equals to negative 1 over 3x. That's it. And that would be the same equation as this one, the same line. And of course, the line declines without looking at any graphs because the slope is negative. Any question? Anything that was not clear? Or you want me to go over one more time? Okay, let's move on to a self-check question. And again, those are not graded. The line y minus 5 equals to 1 over 6 times x plus 1 passes through the point what and has a slope of what? What do you think? You have options? I'm going to change the screen in about 30 seconds. Okay, and here's the question one more time, and this time you're able to select your answers. Okay, I'm going to share my final answer. So you're able to, when you get the recording, you can pause the video and work on the questions yourself and see if you get the same answer as the answer I'm going to show you right now. And the answer is C. C is the right answer. The point is negative 1 and 5. See, it's a plus, but originally the form has a negative. So negative times a negative is a positive. That's why we have a positive. So negative 1 is the x coordinate. 5 is just a 5 because the form has a minus and stayed as a minus. So 5 must be the positive. and then the slope is 1/6. So right away, you should have eliminated those answers. Any question on this self-check question? Okay, let's move on to another form, slope-intercept form. And from the name of the form, it uses a slope, which is m, as you see here in the form. It's an m, and also uses the y-intercept, with a point where the line intersects the y-axis. This is the y-axis, and this is the x-axis. Okay, let's see how can we use this form to graph the line. So graph y equals to 5x plus 1. From looking at the equation, I should know exactly which kind of form is that. It's the slope-intercept form. M times the variable x plus b. B is the y coordinate of that point where the line intersects with the y-axis. Whenever you see the b in the slope-intercept form, you can conclude that the point where that line crosses the y-axis is 0 and b, whatever b is. So from there, I was able to extract one point. I know it falls on that line. And of course, m would be the slope. So how can we graph that? Well, I'm given a point. It's not a direct given, but I know that that 1 is actually indicating that 0 and 1 is the point where the line intersects the y-axis. So let's plot that on the coordinates. It's 0 and go up 1. So this is the point here. So this is 0 and 1. I need a second point. As you know, we have to have at least 2 points to define our line, but we have a slope. So we know how to use a slope to find the second point. So 5 is actually 5/1. 5 is the rise, and the 1 is the run. I'm going to start from my point here, go up 5, 1, 2, 3, 4, 5, and then go to the right once. And that would be my second point that I'm sure it is on the line y equals to 5x plus 1. And that's it. So the second point is 1 and 6 using the slope. And I'm just going to connect the lines. And here you go. This is the first line. The second line, similar, y equals to -4x minus 2. I need to be careful when I see the signs are different than my formula. I need to pay attention to that. Here it's a plus, but it's a minus here. I need to be careful. Now, the -2 at the end tells me that the y-intercept is 0 and -2. And also I have a slope. So let's plot the point first and then go ahead and start from there and use the slope to locate that second point. So 0 and -2. So this would be the first point on the line. It's the y-intercept. The slope is -4/1. -4 is the rise and 1 is the run. Start from my point there. The rise is -4. I need to go down 4 because my rise is negative. 1, 2, 3, 4. And then the run is 1. So here is a second point. So far we have the point 0 and -2 that was concluded from the equation. And then the second point is 1 and -6. 1 here and then -6. And then connect the points. And that would give you the graph of the line. Here you go. That's it. Questions? Okay, let's go to another question. Find the slope-intercept equation of the line that intersects the y-axis at 0 and 8 and has a slope of -4/3. Okay, so in this question gave us actually the b, which is part of our form here. So this is the y intercept, and we know that B is the y coordinate of that point, so B equals to 8. And the slope is -4/3. I can easily put that together and give the equation of the line, -4/3x plus 8. And that's the equation. Another question? Oh, it's a self-check question. On the same form, the equation of the line L, we just gave it a name, L, is y minus 5 equals to 2 times x minus 3. This form reminds you of which form? The equation of the line L in slope-intercept form, which is, I just gave you that form, the template of that. The definition of that is what? So in here, the question gave you the equation of the line using what? Using the slope or point slope form. And it's asking you to use this and make it into the slope-intercept form. How can I use that to get to this? I'm just looking to see if I need to give you any hints. But remember that you have already m here. And this formula used m. So m is there. Now, the only thing I'm missing, and it's not given in the point slope form, is b. B is the y coordinate on where the line intersects the y-axis. Is there any way that we know of that we can use this equation to find this point and we would be able to find B? What do you think? Okay, I'll leave you to think about that and maybe I'll go over this together. So you can have your time and then I'll change my screen in a few seconds. Okay, I'm gonna change the screen to give you the options. Here you go. And I think I'm going to go over that question with you just to show you another kind of a question that you may see in the exam or you may see in your practice questions or self-checks. Okay, let me then show my final answer. The final answer is C, but let's go over this together. So the slope-intercept form uses a slope and the y-coordinate of the y-intercept. Now, for now, I know y equals to 2x plus or minus what? I need to figure out the rest. The rest, actually, I am able to find the y-intercept by setting x equals to 0. Since I have an equation for that line, I can say, well, when x equals to 0, what would be the y, which is the b? So I'm going to use the equation y minus 5 equals to 2 times 0 minus 3. Then it's y minus 5, simplify. 0 minus 3 is a -3 times 2 is a -6. Then solve, then add 5 and add 5. Y equals to, that's gone. -1. B is -1. The point where the line intersects the y-axis is 0 and -1. So I can continue with my equation, say that y equals to 2x minus 1. This is the equation of the line. These two equations are equivalent. They just look different, but they are for the same exact line. Any questions? Okay, let's move on to how can we solve a system of equations using only graphing? Remember in Unit 2, if I'm not mistaken, we have learned how to use algebra to find the point which is the solution for the system of equations. That point is an x and a y value. With graphing, our solution would be a point, the point of intersection between the line 5y minus 2x equals to 16 and the line 3y plus x equals to 3. What I'm going to do, I'm going to show you the graphing method, and then I'm going to show you the algebraic method, and then we can compare our answers. If they both will give us the same answer, they should. So solving a system of equations using graphing is you will graph line 1, graph line 2, and find on the graph the point where the two lines intersect. That point is the solution. Okay, let's do that together. Now, I'm going to use the double intercept method. It would be the easiest method, I think it is, for graphing a line. So I'm going to divide my screen into two halves. That half is for the first line, 5y minus 2x equals to 16, and this half is for this line, for graphing this line. The second line, 3y plus x equals to 3. Now, the double intercept form, it makes me set the x once equals to 0 and find out the y, and the other time set the y equals to 0. What would be the x? What would be the x? So let's do that together. So using this equation, I'm going to say, well, 5y minus 2 times 0 equals to 16. Then 5y equals to 16. Divide over 5 and divide over 5. Y equals to 3.5. Your first point that you have located for line number 1 is 0 and 3.5. That's the first point. The second point comes from setting the y equals to 0. Let's do that. The same equation, the same line, this line. So 5 times 0 minus 2x should equals to 16. That's gone. Then negative 2x equals to 16. Divide over negative 2 and divide over negative 2. That's gone. It's a 1. Then x equals to negative 8. Your second point that you'll be able to use to graph this first line is negative 8 and 0. Let's plot that on the coordinate plane. So we have 0 and 3.5. That's 3. So that's the half here. That would be one point. And the other point is negative 8 and 0. So these are the 2 points here. So connect the points to graph the first line. And here you go. This is the first line. We're not done yet. We need to graph the second line. Use the same method, the double intercept form. So I'm going to do the same thing. I'm going to set the x equals to 0 once. I have to figure out the y. And once I'm going to set the y equals to 0, what would be the x? Use the equation. So 3y plus 0 equals to 3. Then 3y should equal to 3. Divide over 3 and divide over 3. Y equals to 1. Your first point on the second line is 0 and 1. The second point, set the y to 0. Then 3 times 0 plus x equals to 3. That is gone. It's a 0. Then x equals to 3. The point is 3 and 0. Plot the 2 points. So 0 and 1, that's 1 point. The second point is 3 and 0. And connect the lines. Now, the point of intersection is this point. This is the point of intersection. What is that point? From looking at the coordinate plane, that is a -3 and that is a 2. The solution for that system is -3 and 2, meaning that the x value is -3 and the y should be 2. That's it. Now, let's remind ourselves, how did we do that algebraically without doing any graphs, just to make sure that it is the right answer. Okay, so what we did back then is we have these two equations, 5y minus 2x equals to 16, and the second one is 3y plus x equals to 3. Our goal back then is to make one of the variables having the same coefficient but with a negative, with an opposite sign. The easiest one I can change is the x. That's a -2 and that's a +1. So let's multiply the second equation times 2. If this happens, then this will be that here. The first one will stay the same, 5y minus 2x equals to 16. Multiply 2 times 3 is 6y. 2 times 1 is 2, so plus 2x and equals to 2 times 3 is 6. Now you need to add both equations. So 5 and 6 will give you 11. Why? That's gone, equals to 22. Divide over 11 and divide over 11, y equals to 2. And then use the y in one of the equations to find x. So since y equals to 2, then I can say 3 times 2 plus x should give me 3. 3 times 2 is 6, plus x should give me 3. Solve, so you're going to have x equals to 3 minus 6, then x equals to -3. And again, the solution is -3 for x and y is 2, the same thing that we had got with using only graphing. So those two methods are the same. This is algebra and this is graphing. Just want to show you that it falls in place and everything is right, whatever method you want to use. If the question asks you to graph, then graph. If asks you it didn't specify, then do whatever easier for you. Any question? Anything that was not clear or was confusing, or you want me to go over one more time? Okay. Then that was the end of my math part of the webinar. So far, we had gone through the general form, point-slope form, point-intercept form, how to use these to graph or to come up with the equation itself, and how to use graphing in solving the equation. How would you prepare for the exam? Of course, you want to study your study unit. You want to maybe watch the recorded webinar whenever you receive it. It's typically a day or two after the webinar day. Do the practice questions, the self-checks. They are not graded, I know, but they are given for you to practice. And also, you need to check your answers with the answer key that you are provided within your unit. Also, an outside resource that I think it's valuable resource would be khanacademy.org. On the top left side of the screen, you're going to click on subjects and select Algebra 1. And from the list, the list of lessons given, you want to select linear equations and graphs and start from intro to slope-intercept form. This is where the second part of this unit starts. So that's an outside resource. You don't have to use it, but if you would like extra help and extra practice, you can go there. You can call the school from 9 to 6 Eastern Time weekdays. You can schedule your own appointment one-to-one with a teacher assistant or an instructor. You can use this link to choose your course and time. You can text message this number and type in learn, and that way your message will go to the education department. Someone of us will get back to you. If you have a brief question, text messaging would be the best. If you have a long question, you want to email your instructor. I have brought the two kinds of accounts that we have students on, either this one or that one. Choose whichever platform you are on and follow those steps on those squares, and you'll be able to send your instructor for any subject really an email. And that's it. Thank you for your attendance. I'm going to wait for a few seconds to see if you have any questions for me, even if it's a general question on the program, on the course. I'll be happy to assist you with that. And if not, I would ask you to take a survey, just one question that you want to answer, just to give a feedback for myself if this webinar was helpful for you or not helpful at all. So your opinion really matters. So just take a few seconds to take the survey question. I'm going to wait for a few seconds to see if you have any questions for me. Okay, well, if you think of any questions, you can email, text message, or set up an appointment if you need help with your subject. Thank you for your attendance and your attention. Good luck in the exam.